Earth Systems 3209, Unit 3, Earth's Materials. This presentation will reference the textbook in Chapters 2, 3, 6, and 7. It can also reference the curriculum guide in Appendix A and B. Unit 3, Topic 2.1 will discuss rocks and the rock cycle. The focus of this presentation will be on defining rock and recognizing the connection between minerals and rocks. We will also focus on the rock cycle diagram and explaining the origin of the three rock types. And we will explain the different processes that link each rock type to others. And these are represented by arrows within the rock cycle. When we look at the rocks in the rock cycle, first we need to define what is a rock. A rock is a consolidated mixture of one or more minerals. Rocks are generally composed of more than one material. For example, granite consists of several different minerals, namely quartz, feldspar, hornblende, and mica. From the diagram below, we can see that quartz is represented by this light area in the rock. Orthoclase feldspar is represented by the brown to pink area in the rock. And amphibole is represented by the darker areas in the rock. These collections of minerals make up the rock granite. When we look at the rock cycle is a cycle between three main rock types. The first rock type would be igneous rock. Second rock type would be sedimentary rock. And the third rock type will be metamorphic rock. All these rock types are interrelated through the rock cycle. Information on the rock cycle can be found in the text on pages 15 through 17. Some common rocks include igneous rocks. We have granite, gabbro, and diorite. Three of these igneous rocks form within the Earth and are therefore called plutonic igneous rocks. We also have rhyolite, basalt, andesite, obsidian, pumice, and scoria. These six igneous rocks form on the surface of the Earth and are called volcanic igneous rocks. We also have sedimentary rocks, such as conglomerate, breccia, sandstone, siltstone, and shale, and also limestone. Some metamorphic rocks include slate, phyllite, schist, gneiss, marble, and quartzite. All of these rocks can be found interconnected with one another throughout the rock cycle. When we look at igneous rocks are rocks formed by the cooling and hardening of hot molten rock. If the molten rock is located within the Earth, it is called magma. If the molten rock reaches the surface or near the surface before it cools, it is then called lava. Lava can also exit the Earth through volcanoes or fissure eruptions at the Earth's surface. There are two classifications of igneous rock. Igneous rock that forms inside the Earth is called intrusive or plutonic, and it forms from magma when magma cools beneath the surface. Magma generally cools very slowly beneath the surface and can take thousands to hundreds of thousands of years before it is cooled. Therefore, the crystal size in plutonic igneous rock is usually coarse, large crystals. In comparison, volcanic igneous rock, which is also called extrusive igneous rock, forms from lava. When lava comes to the surface, it generally cools relatively quickly, in a matter of days or months, and the resulting crystal size is usually small. So volcanic extrusive igneous rocks have a fine-grained texture. When we look at sedimentary rocks are formed when weathered products of pre-existing rocks have been transported, deposited, and compacted or cemented to form solid rock. This process is called lithification. Usually, sedimentary rocks are formed in marine or water environments where sediment is deposited by streams and rivers. Most of the Earth's surface is igneous rock, but at the surface, the rock that we see covering the Earth's surface is majority sedimentary rock. There are three classifications of sedimentary rock. Number 1, clastic or detrital sedimentary rock. These are rocks made up of rock particles that result from erosion and weathering. Number 2, we have chemical sedimentary rocks, which results from chemicals in solution, which fall out of solution by precipitation, or chemicals can be left behind by evaporation of the water environment. And we also have a third type of sedimentary rock called biochemical. And these rocks form from organic remains. A third rock type is called metamorphic rock. Rocks formed below the Earth's surface when pre-existing rock is altered by heat, pressure, and chemical active fluids. This results in a changing of the rock to form metamorphic rock. When rocks change by metamorphism, rocks generally change in size, shape, texture, and also the minerals can change within the rock. Metamorphism varies in degree. A high-grade metamorphic rock is a rock that has undergone extensive change by heat and pressure. Such a change is seen when granite changes to form the metamorphic rock gneiss. In comparison, low-grade metamorphism will occur when a rock only undergoes a small degree of heat and pressure, and such a change can be seen when shale changes to form the metamorphic rock slate. When we look at the rock cycle, a good place to start will be underneath the Earth, where we have molten rock called magma. Magma underneath the Earth can cool and crystallize, and when it do, it forms an igneous rock. Igneous rocks can either be classified as volcanic or plutonic, depending upon the environment in which they form. Igneous rocks then can be exposed to weathering and erosion. Weathering and erosion can occur by wind, water, and ice, which affects the rock and breaks the rock down to form different particles. These particles are called sediment. The sediment that results can be sand, silt, or clay. And generally these sediment particles are then transported to an environment in which they will form sedimentary rock. In order for sediment to form into solid sedimentary rock, a process called lithification, it must undergo two processes of compaction and cementing. Once the sediment is compacted or cemented, we generally form solid sedimentary rock. And sedimentary rocks are classified as clastic, chemical, or they can be organic or biochemical. Once you have sedimentary rock formed and it gets buried deep within the Earth, sedimentary rocks can undergo heat and pressure to form metamorphic rock. Metamorphic rock is a rock that results when the pre-existing rock undergoes some sort of change, generally by heat or pressure acting on the rock. Metamorphic rock within the Earth can further undergo extensive heat, where melting can occur again, and then we're back to the beginning of the cycle where we started as magma. Now this rock cycle only represents one cycle. There are also other processes, or what we call shortcuts, that could occur where one rock type can form into a different rock type. The arrows here represented in blue would represent some of the shortcuts. For example, if you have an igneous rock that is just crystallized from molten rock magma, or even a molten rock on the surface called lava, it forms an igneous rock. This igneous rock can then be melted once more if it's buried or exposed to extreme conditions where heat increases. The melting of the igneous rock will again form magma. Another avenue that the igneous rock can be exposed is it could be exposed to high heat and high pressure. If the igneous rock is directly exposed to heat and pressure, it can go directly to a metamorphic rock. If we look at sedimentary rocks generally get buried within the earth, therefore it undergoes heat and pressure to form metamorphic rock. But some sedimentary rocks are exposed at the surface and are exposed to the agents of erosion, such as wind, water, and ice. So if sedimentary rock is experienced through weathering and erosion, it can once again form into sediment. When we look at metamorphic rocks that are exposed to heat within the earth tend to melt. If they melt, they will once again form into magma. But a metamorphic rock can also be exposed at the surface if the earth was uplifted and a lot of erosion and weathering has taken place. If metamorphic rock is exposed at the surface, it can become weathered and eroded and again form sediment. So the blue arrows in this diagram represent some of the shortcuts that can occur within the rock cycle. So in review, there are three main rock types. We have igneous rock, sedimentary rock, and metamorphic rock. And all three rock types can, under certain conditions, be exposed to the different processes responsible for changing one rock into another. Igneous rocks can melt to form magma. Igneous rocks can undergo heat and pressure to form metamorphic rock, or igneous rocks can weather and erode to form sediment, which in turn will form sedimentary rock through the process of lithification. Again, sedimentary rocks can undergo heat and pressure if buried to form metamorphic rock. It can also be exposed to the surface where it undergoes weathering and erosion to form sediment, which will again become lithified, become sedimentary rock. And the third rock type, metamorphic, can undergo melting to form magma, where it will form igneous rock once again. Or metamorphic rock can be exposed to the elements or agents of erosion and weathering to form sediment, which in turn will turn back into sedimentary rocks by lithification. So the rock cycle is a cyclic nature where the three rock types can change from one form to the other. Let's look at some examples. Example 1 from a past public exam. Question states, which statement is true about the rock cycle? Response A says magma cools and crystallizes to form metamorphic rocks. We know that this process is incorrect, because if magma cools and crystallizes, it will form igneous rock. Choice B says that metamorphic rocks lithify to form sediments. Choice C says sedimentary rocks may contain igneous rocks or metamorphic rocks. And choice D says that weathering affects only igneous rock. But through the rock cycle, we notice that weathering and erosion will affect any rock type that is exposed at the surface. So our best response and correct answer for this question will be C. Sedimentary rocks may contain fragments of igneous rock or fragments of metamorphic rock. When both metamorphic rock and igneous rock are eroded, they then get transported and deposited and can be included within the sedimentary rock. So the answer to this question is C. Next question reads, what rock forms when pre-existing rock is altered as a result of heat and pressure. Heat and pressure are two of the agents responsible for the formation of igneous rock. Heat and pressure are the two agents that are responsible for the formation of metamorphic rocks. So the correct answer to this question will be B, metamorphic rock. Igneous rocks form from the cooling and solidifying of magma or lava. Sandstone results when sand gets lithified, which is a sedimentary rock. And also sedimentary rocks form by the lithification process, the compaction and cementing of pre-existing rocks. So the answer to this question will be B, metamorphic rock. Example number 2. Let's look at the questions listed below. Which is a consolidated mixture of minerals? So when we read the question, we're looking for a mixture of minerals that are all consolidated in one solid state. This was our definition for a rock. So the answer to this question will be D, rocks are consolidated mixtures of minerals. Next question. Which processes are responsible for the lithification of sediments? Now when we read this question, it focuses on lithification of sediments. And the lithification is the process by which sediments are changed into solid sedimentary rock. The two processes that form solid sediments into a solid sedimentary rock will be cementation and compaction. So the answer to this question would be A. Cementation and compaction will lithify sediments into solid sedimentary rock. Your turn. Take time and complete the following questions. In the diagram below, rock types and materials are indicated by numbers, and processes are indicated by letters. Indicate the rock types and materials and the processes for the rock cycle diagram by completing the table below. So you can stop the recording now to prepare your answer, and the solution will follow on the following slide. When we look at the answer to this question, rock types and materials are indicated by numbers. So if we start off with number 1 being magma, we know that magma will go through a process, indicated here by A, to form a rock type. So the process of A is the magma cools and crystallizes. So we should indicate that for process A. When magma cools and crystallizes, it will form a rock type called igneous rock. Igneous rock then undergoes weathering and erosion, which is listed for process B. When any rock is weathered and eroded, it will form sediment. So sediments is located in box B, in box 3. When sediments change into solid sedimentary rock, which is process or box number 4. Process C, which changes sediment into solid sedimentary rock, is compaction and cementing. So that one should be entered in slot C. When sediments undergo heat and pressure, which is indicated by D, it will form the third rock type, which is metamorphic rock. So sedimentary rock 4 will undergo heat and pressure, indicated by process D, to form metamorphic rock, which is box 5. Then to complete the cycle, metamorphic rock undergoes a process which causes it to melt to form magma, so E would be melting. Complete the following question. Take the time to stop the recording now and prepare an answer for the following question. In relation to the rock cycle, explain 2 processes responsible for the formation of sedimentary rock. When we look at the solution, in relation to rock cycle, two processes that form sediment into sedimentary rock. The process itself is called lithification, and this is a process that turns sediment into solid rock. This process is carried out through compaction and cementing. Compaction occurs when the weight of the overlying material increases. Compaction forces the grains closer together, which reduces pore space and eliminates some of the contained water. And in the process, the small fine sediment will actually join together and fuse. Compaction usually occurs in finer sediment, such as silt and clay, and it don't really cause sand and pebbles to actually form the sedimentary rock. In order for sand and pebbles to form solid sedimentary rock, we also must have a process called cementation. Cementation occurs when water moving through the pore spaces in between sediment, such as sand and pebbles, and it causes chemicals to precipitate, which is dissolved in solution. These chemicals may precipitate as new minerals in the pore spaces, and this causes the particles to stick together. So once the particles have cement precipitated on the surfaces, they tend to stick the particles together. So a combination of compaction and cementing are two processes that are responsible for causing sediment to turn into solid sedimentary rock, which is a process called lithification. In summary, we have three rock types that we see throughout the rock cycle. Those three rock types will be igneous rock, sedimentary rock, and metamorphic rock. And when we look at the cycling of the three rocks, we generally see magma, which cools and crystallizes to form igneous rock. Igneous rock can weather and erode to become sediments. Sediments then can compact or be cemented to form sedimentary rock. And sedimentary rock can undergo heat and pressure to form a metamorphic rock. And metamorphic rock can then be exposed to heat and melt, and the cycle starts again.